Okay, I think it's time to start, so let's try to start on time. So first of all, my name is Eric. I work for this company up there called Nicta. It's in Sydney. It's an awesome company. We're hiring. So if you want to work in Sydney, please talk to me. The thing we're going to talk about today is software specifications, and more precisely, how you can write software specifications using specs2 in Scala. And we are going to try to take things very progressively, and how do you get started with it, and how you can understand exactly how it works, and add more and more stuff to make your specifications more and more useful, with all sorts of tricks and funny things you can do with them. And maybe at the end, I will talk a little bit about what's coming up in the next version. So before we see any kind of code, I want to talk about something which I call the gap. And that's a gap we have to fill, and that's very real, between two different worlds. And you have, on one hand, the worlds of the requirements, which is the world of, okay, what is my system supposed to do? So that's an idea, in someone's head, somewhere. So you just have your regular words to express this idea. So you use an informal language. The trouble is that this idea has to fly from one hand of the screen to the other one. And it has to become formal at some stage, so it has to become some code. So there's some kind of magical transformation process to do that. And that's essentially what you do when you write a software specification. You try to make the informal a bit less informal until there's someone who can perfectly codify this into some code. So the primary artifact which you have in the business world, in the world of requirements, is just pure text. And whereas the primary artifact you have as a developer, and that's your main tool, is code. That's cool to have code. And they both have advantages and drawbacks. So one very cool thing with text is that generally it can be very readable. So, I mean, you can pass it to anyone. It can be read very easily. Doesn't necessarily, you don't have to know the syntax or whatever, because, I mean, we've all been to school, so we're supposed to know the syntax. But the cool thing about code is that code can be executed. It can be verified. It has all sorts of very cool properties as well, so you can check if it's not ambiguous and so on. And so what you tend to have in your software specifications as text is that they are very often, they are extensive. You have lots of repetition and so on. Whereas in the code, you have very nice tools to refactor your code, which is something we don't have for pure text. And the other thing which we do very well as developers is version this information. So we have very powerful versioning tools. And if you look at software specifications written as pure text, very often the version numbers that they are using are auto-incremented, they are manual, they don't keep in sync with the code, and so on and so on. So you have different kind of properties on both sides. And you have different tools corresponding to where you want to write your specification closer to each of those two sides you want to write your specification. So if you take a tool like Word, it's clearly in the informal text world. And if you use JUnit as a specification tool, you're all of a sudden in the world of code, and you're in the world of developers, knowing all the syntax and the defs and the classes and all these things. And year after year, you've seen different tools trying to bridge this gap in different ways. So you have something like Cucumber, which is more like having text files, which can still be read as text, but also they can be parsed, and you can have some code relating to this text and trying to bridge this gap. And you can have specs2, which is definitely on the developer side, so that's a developer tool. It's not a tool that you would give to a business analyst or to someone who doesn't know how to code. But even in specs2, we still try to preserve the possibility to write some text, or even to add some images or some diagrams or some tables, if that makes sense, to make the specifications a bit more readable. So let's make our first steps with specs2. Where do you start? What is even a specs2 specification? So this is it. So that's a specs2 specification. That's one way of doing it. And as you can see, that's pure Scala code. So you have a new class extending specification, and you define one method, which is essentially in this style is going to contain all your texts, all your description of what is the system supposed to do. And that's pretty nice because, again, that's pure text, so you're free to introduce the subject, to explain what are the objectives, why you are doing this, and then give some examples of exactly what you mean. And when you want to become more specific about what you really mean, you can reference this text and use E1, E2, E3, and say, okay, this is exactly what I mean. And for this, you have a DSL using matchers, and you are able then to use code, and this code is verified, executable, and so on. So it has all the nice properties of code. So this is where we kind of bridge this gap by putting the text and the code together. And you can execute this specification using SBT. You have this kind of reports. You can also use IntelliJ, for example, that runs as well. So that was for the start. Then we need to know a major thing about specs2 is that there are two styles. And in Scala test, there are 5 or 6, something like that. But there are two styles because they correspond to two different ways of writing the specifications, which are very different. So the first style I showed you was a style where you have all the text in one place and then all the code in another place. This can be good because if you come 3 months later, you can have, it can be very easy to read what the system is doing just by reading the text. And sometimes the code in test cases can grow a bit large, so it would be a bit harder to read the code inside pieces of text. On the other hand, sometimes it's also useful and nice to have a piece of text with your description, a piece of code, a piece of text, a piece of code, and that's generally what you're used to if you come from JUnit, from RSpec, from all those tools. So you're used to this style. So this is why, oh, sorry, I should show this. So this is why this style is also supported in specs2. So you have basically, when you start your first specification, you have to decide, okay, which style am I going to use? And they are both very valid choices. The next thing where you are going to use, and there are lots of them in specs2, is matchers. So you have lots of ways of specifying exactly what does it mean for the system to behave properly. And equality is, of course, the thing you're going to use the most. So there are all sorts of different variations of equality. Basically, that's using under the covers the Scala equality. So you need to have a well-behaved Scala equal operator. But you also have typed equality, because one of the issues of the Scala equal operator is that it's not typed. So you can have some type errors slipping through. And it's nice to have also a typed equality matcher, which you can use, and then the compiler can tell you if the two things really have compatible types. So the question you might wonder is, okay, why do we even bother using this form with matchers and A must be B and things like that? Because we could just use conditionals. You can just use Boolean expressions and just to say A equal to 1. So the good thing about having something a bit more structured is that we can have better failure messages. So for example, if you have two different strings, it might not be completely obvious to see why they are different. I don't know if you can spot it right away. No, maybe not. Yes, I heard it. Yes. So in that case, specs2 is going to try to do a difference on the strings, and is going to try to show you as much as possible where there are differences in your strings. So sometimes it's just on one line, but it could be a larger piece of text. The other thing that it's going to try to do is, and that's very tricky, when you have two things which are different, but they happen to have the exact two-string representation. So how do you display them on screen? You say A is not, well, A. It's not the same A, but they have the same way of being represented. So in that case, specs2 will try, not in all the cases, but will try to tell you, okay, those two things look the same, but they don't have the same type. So maybe you made a mistake somewhere. Check out the types. So that's for equality, and otherwise you have in specs2 lots of other matchers which you would expect for all the most common data types that you have, like on booleans, on strings with regular expressions, on numerical values, on options, ethers, and so on. And then there's another class of matchers which you are very likely to use from the beginning, which is traversable matchers. And so this was not exactly written like that in the first versions of specs2, but this has been refactored to have a very consistent look and feel. So you are basically going to say, my sequence must contain the element 2. That's one way of checking something. But sometimes you're not looking for an exact check. You're looking for something which looks like 2. So instead of saying it contains 2, you can say it contains something that's equal to 2, but maybe is slightly superior to 1.5, and things like that. So you can put matchers inside the contain operator. And you can even put a function taking the element and returning another expectation. So there's a small DSL for collection matching, which I think should cover most of your use case if you need to match each individual element in the collection. There's another use case which looks very similar, but which is actually a bit different, is that sometimes you want to assert a property on the collection in its entirety. Like if you say my collection must contain the elements 2 and 3, that's not a property of individual elements in the collection, that's a property of the collection as a whole. So in that case, you can say something like that. So it contains all of 3, or it contains exactly 3, 1, 2, but we don't really care by default about the order. And if you care about the order, you can say something like, oh, it contains something that's greater than 0, something that's greater than 1, greater than 2, and it must be in order. Otherwise, it's going to fail. So you have lots of those predefined matchers in specs2, but that's not always enough. I mean, you have your own data types. You have your own things you want to use matcher on. So the thing you want to do in that case is create your own matchers. And the easiest way to do that is simply to take an existing matcher and transform it slightly to create a new matcher doing exactly what you want. So in the first example, we're taking the B matching matcher, taking a regular expression and checking if 2 strings are matching with a regular expression. But you want to say, oh, before running it with the regular expression, I want to trim my actual value. I want to trim it. So you adapt one matcher with a function, and that creates a new matcher. So that's one way of creating a new matcher. The second example shows another way. You have a matcher, but you want to invoke it on an operation which maybe might fail the first time, maybe might fail the second time, but maybe it's going to be okay on the third time. So you can transform this matcher into an eventually matcher that's going to retry the match until it succeeds, or maybe not. And eventually, if you don't find a way to combine the existing matchers to do exactly what you want, well, you can create your own. And it's very easy. There are implicits transforming a function, returning a Boolean and a failure message into a matcher. So if you want to check if something is even, just create a function, taking an int, checking if it's even or not, that's the condition, and just returning a failure message with the int if it's not even. And you have a brand new matcher. And you have plenty of other matchers. So the one I talked about are included in the specifications trait. As soon as you extend it, you have all of those matchers. But you have many others which are optional. Generally, you will need to add more traits to the specification to get them. So you can use matchers for JSON, for XML, for maps, to check if an expression is terminating or not. You have matchers for case classes. And that one is really cool because it's actually using a macro to generate new matchers for each of the member of your case class. So you don't even have to write the matchers. It's being written for you. So I really encourage you to just have a look at the documentation or the user guide and try to look for all the matchers and create your own matchers. I mean, it's very important to have nice, concise tests, or I should say examples and specifications. And in order to do that, you will get that if you have matchers which exactly express your intent and not trying to transform the data until you can get back to a B equal matcher. Okay, so that's for with this, you should be able to create your first specification, create some text, create the first expectations with A must do something. The next thing you need to understand is how the specification is going to be executed. So the first point is that there are different modes of reporting failures in specs2. The first one, which you have by default in an acceptance specification, is that the last value wins. So it's a purely functional style. So there's no exception being thrown, and that's a bit different from what you would find in JUnit or other testing libraries. So in that case, in this example, even if 1 must be equal to 2 is obviously false, this will be ignored because this is just a statement that's just hanging in the air. There's no one to collect it. You can still connect the two statements by using AND. You can say my first line and the second line, and that's going to be the new value you return. So you would wonder why use this style. And this style actually encourages you and forces you in a way to put just one expectation per example, which can be considered as a good practice, because if there's an issue, if there's an example failing, you know exactly what's wrong. It's just failing for one reason. But there is another mode of creating failures, which is thrown expectations. And the thrown expectations tray, which you see here, is mixed in by default into the unit style of specifications. You know, the one where there is a bit of text, a bit of code, a bit of text, a bit of code. And in this style, which is, again, that's a lot more familiar to many of us, is just as soon as something goes wrong, we throw an exception and all the rest is not executed. Which can be useful. I mean, if you spend some time creating some elaborate setup that takes, you need to initialize the system and so on. So it takes a lot of time to set up the thing you wanted to specify, to test. It's cool to be able to have lots of different expectations, each on a different line, right? It's nice to have this. So it's also, again, it's a very valid way of using expectations and using exceptions in that case. You just need to know exactly what you want to do. And then there's a third mode, which I think is pretty original. I haven't seen that in other testing libraries, is that sometimes you might want to just collect everything. So you spend some time setting up a system, you have a bunch of things you want to check. You don't necessarily want to stop after the first failure. Maybe you also want to have the other checks being performed. So with the all expectations trait, you can say exactly this, and it's going to execute everything and then return you only what failed and what was okay. So that's something you need to be aware when you're using specs2. You have these three modes, and they are all useful. The next thing, which again is a default, and that's my opinion on how it should be, I think it should be the default, is that all the examples are by default executed concurrently. And I think it's good because that makes the execution fast. And also it forces you to think about isolating your example, isolating your state. It's very annoying when you have something failing because another test was just running before, didn't set the proper thing, and you actually just moved the test up in the class and then it broke everything. And things like that, it's very annoying. So by default, it's concurrent. And so if you execute a specification, yeah, you have the traces like that. It can be 2, 1, 3 in any order. But you can control this concurrency. It doesn't have to be concurrent all the time. Again, it makes sense sometimes to have some checkpoints to say, okay, you've executed a bunch of stuff concurrently, and now I want to create a step. I want to say, okay, stop here, wait for everything to be executed, maybe do something, and then go on with the rest of the specification. So this is what we do here. We run the example one, we stop here, and then the rest is again concurrent. And so not only you can create a step to say, I want to stop here, but you can add conditions on this step. And you can say, okay, you stop here, but if anything was failing before, don't even bother with running the rest of the specification because I know that the rest is not going to make any sense. It would be useless to have all these failures. Just keep the rest of the examples. And sometimes for some testing that we do, like some acceptance scenario testing, and we interact with an external system keeping some state in just action A, action B, action A, action B, A, B, C, D. We want things to run really sequentially. And in that case, there's an argument called sequential, which you can pass inside your specification, but which you can also pass from the command line. And whatever the examples are doing, they are going to be executed one after the other. So that's for the concurrency. The last thing you need to know about the execution is, and again, about how to manage mutable state, which you might have in your specifications, while still keeping this specification is still concurrent, even if it's accessing a mutable variable. And the trick is that each example that's going to be executed is going to be executed in a fresh copy of the specification. So each of these examples will have a fresh copy of the stack. So even if they run concurrently, this is not a problem. They will have a fresh one. So that's it. Now you know how to write a specification, choose between the styles, know how you want to create your failures, know about the concurrent execution. The next thing you might want to do when you develop your specifications is that it's very rare to develop everything at once. So you start by writing a bit, implementing a bit, and then adding more cases. So generally, you want to be able to select one of the examples just to, let's say, okay, now we focus on this one. So you want to be able to select it from the command line. So one way to do this is to use EX for example, and you say, okay, I just want to select the example with the contain word in it. And specs2 is just going to rerun just this one. Another thing which you can do to rerun just specific examples is to use tags. So there's one way of creating tags which is conventional, which you would find in other libraries. Just put a tag after an example. And then the example is tagged as X. So if you say include X, it's just going to rerun this one, not the rest. And there's this concept of a section, because essentially in a specs2 specification, the thing is just a big list of text, example, text, example. That's just it. So you can create a section and say, okay, that's my Y section, and I just want to run what's in between the two section markers. And that's pretty nifty sometimes, because that means that you can rerun your specification and, for example, progressively slide the section down. Or just say, okay, I want to restrict to the first half of the specification, and then I just move one marker, and I will test the rest, the bottom half. So that's a very cool feature. You can also have overlapping sections, and you can say, oh, I just want what's in between, like only Z and Y, and that will also work. So that's an example where, as you can see, only two examples are being executed. And finally, about selecting stuff to rerun them, one very frequent use case is when you're just trying to fix stuff and you want things to work. So you had some failing examples, and you just say, okay, can you please rerun everything that failed before? So X is the small symbol that we display when there's a failure, and you say, okay, if something was X, can you please rerun that? And you can use other symbols like a bang, exclamation mark is going to be an error. So can you please rerun everything that was an error or a failure? And specs2 will rerun just that, just the thing that failed. And hopefully you'll fix it. Okay, what do we see next? I think the last piece of information for a quick start, for knowing how to use the library at first, is to know how to manage context. So very often we have to set up systems before we do anything. We have to create data, or we have to clean up. We have to shut down resources and so on. So one way to do it is to use a trait called before example. So before example asks you to create, to implement a method called before, where you are going to do your setup. So that's the easiest thing you can do. And this method will be called before each example. And yes, I must say that there's an after trait with an after method, and then there's even a before after trait where you have those two methods combined. And then if you want to be a bit more fancy, and many times you have to do that because you want to execute your examples in a context. You want to execute your examples in the context of, I don't know, a database transaction or an HTTP request. So in this case, you can use the around example trait, and you define this around method, where, as you can see, the R is going to be the body of your example, the piece of code you want to execute. So you can do something before, you can try to execute your example, and then finally you can close resources when you're done. And so this will print something like that, where you can see, again, you might have the two befores and the two afters together, because again, the examples are being executed concurrently. And finally, I think the most power comes from another trait called Fixture example. So when you do, when you want to specify something inside an HTTP request, not only you want the app to be up with all the resources and all that stuff, but it's very useful to be able to access the request object itself and use it inside the examples. So in this case, I'm just using a string, so it's not a very good context, but if you implement the fixture example trait, you are required to implement a fixture method where you pass this context. So in the fixture method, you initialize your system, you can pass the context to the example, and then you can do some cleanup afterwards. So yeah, here it is. So we use a string and we check stuff on that string. But it could be another string. It could be, you could also use that to execute several times the same example and so on. So there are lots of applications of this context. Every time you have basically to set up something, to shut down resources. But you can also use it to time out your examples, for example. So you can use an around trait, which is going to stop the example from being executed if it takes too long. One application of this we did on a project called Scooby, which is a Scala layer on top of Hadoop, is that we use several of these contents chained together into a bigger context so that we run the thing the first time with an in-memory collection, no Hadoop. So just to check if the logic of maps and filters is okay. If that works, then we run the same thing with local Hadoop. So that should still be fast because that's still on one machine. And hopefully that doesn't break. And then if that works, we run the same code again on the cluster. So we have this progression of contexts, and it's all with just one tray. It's well packaged. So that's cool. So basically by now, you should be able to write your first specification, write use matchers, handle the context, be able to set the context, and so on. So how can you do even better? I don't know, let's try to go full speed. The next step would be how to use ScalaCheck. ScalaCheck is a very, very, very fine library, which is here, ScalaCheck. It really helped me. I mean, I have a few war stories to share if you want to ask me after about using ScalaCheck. But every time you have something which looks like some kind of mathematical property, it's the place for ScalaCheck. Every time you have some data type with all sorts of crazy variations, which I mean, you wouldn't think about specifying all of them by hand. You would use ScalaCheck and use ScalaCheck generators to generate this data for you. This is very, very useful. So in this case, I'm testing very simplistic stuff. The thing which you might notice if you use ScalaCheck on its own in another project is that in ScalaCheck properties, you generally return Booleans, whereas with ScalaCheck as integrated with specs2, you can use specs2 matchers and specs2 expectations in general inside your properties. So you will get the same kind of failure messages that you got in your classical examples. You will get them in those properties. So by default, that shows very low on the screen. So ScalaCheck is running 100 tests per example. So in that case, that means 200 expectations. I really encourage you to, for the hard stuff that you're doing, to try to push this up. And okay, I'm going to share a war story right now. 2 weeks ago, it was not very far back in time, we had some things dealing with date formats and changing those formats into different things. And we had to increase the number of tests up to 50,000 to actually see a problem. And again, it was with DSTs and all this gray area about what do you do about transforming dates and hours when you have DSTs between two different time zones and so on. So it was very useful for us to just once, I would not recommend to leave this setting on your Jenkins server, but just once or twice, try to run a few more tests. Try to run, there's a mean size parameter which kind of control the size of the data structure that you feed in your property. Try to increase those parameters and see if you can really break something. And if that breaks, you will be actually very happy if that breaks, because you will say, thank you, Scala test. But sometimes not everything is a property in a very mathematical sense. Sometimes the best thing you can do to specify something is just give some tiny examples. And one thing I've always liked about writing specifications just in a Word document is the possibility to create tables. I think that tables are an incredible tool. It's very concise. You can cram in lots of very useful information in a table. So when I started working on specs2, I always thought, oh man, that would be cool to have tables in my code. Wow, that would be cool, but isn't even possible. And it turns out that Scala is very flexible. There's a way to bend the syntax to create something that looks like a table. So this looks like a table. This has a header and some values, and it's actually, that doesn't really show up on this example, but this is even type checked. So what you put on the first line influences the type of what you put on the other line. So yeah, there's a form of type checking here. So in that case, you're just giving what changes in terms of data for this directory path function and what's the expected results. So that's a very concise way to put lots of examples into one. And if there's any issue, the table will be displayed and will show you on which row there was a problem. So I really encourage you to use that. That's very useful. And the last thing about being able to run with specs2 is to use Mockito. So I'm not a big fan of Mockito. Let's discuss that after the session. But it can be useful at the boundaries of your system where you have side effects, where like if you're providing a notifier to an external system, you want to check if this notifier interface is really touched, if there's any interaction with it. So there's a syntax for it. It's nice, and those are the Mockito error messages telling you, oh, I was expecting an interaction with my notifier, there wasn't any. Okay, so now we know how to walk, we know how to run. What would be the next step? I don't know, let's be creative. One thing you can do with specs2 is to use the given when then style. I'm not going to spend too much time on this because I've never been convinced of the given when then style. That's one way of doing it, and it is a bit crazy because it's keeping all sorts of mutable states behind the covers. It's trying to be compiled, time checked, so all of these things needs to have the right type to be used there. So that's using shapeless hlists here. So there's a way to do this, but what I want to add, and then when you run it, you have something like that. But the cool thing about working on the given when then style is that gave me an idea of how we could write something which looks like Cucumber in a way, where you have a pure piece of text and which is kind of magically related to the code somewhere. And this is called example groups and scripts and templates. So basically the idea here is that you just rely on conventions. And every time you have a markdown header like that, that says, okay, that's the beginning of a new group of examples. And every time you write your specification by putting a cross, that means, okay, that's something I want to check. That's something I want a developer to come take this sentence here and transform that into some code which can be executed. So this is what you can do. You can implement the previous text by creating those groups and creating those examples. And they don't have real names. They are auto-numbered. So when you execute the specification, it will show up like this. So the first are OK. And oh, the third example here was not implemented because didn't have time, because just wanted to check if the first ones were working. So it's automatically marked as pending. You don't have to do anything for it. And it's numbered, so you know exactly in which group it is and which number it has. So that's one fancy thing which you can do if you want to have more Cucumber-like specifications. Another thing which I think, and now we enter kind of a tips and tricks section of the talk, is one thing you can do, and that's, I think, very useful, is you can access the command line arguments by mixing in these straight command line arguments, what a name, and then you access arguments. And that's very useful because sometimes when you tweak your specification or when you tweak your code, you don't want to all the time having to change your code, execute in SBT, for example, check the results, go back to your code, change something else, recompile, and so on. So it takes a long time. This cycle can be a bit long, especially because of compilation times. So it can be really, really useful. If you can just, from the command line, pass a new argument, change a new parameter. Like, for example, you can change ScalaCheck properties, and you can say, OK, now test. It works fine with 100 tests. Can you try with 1,000? Can you try with 10,000? And so on. And then you execute with this new argument. For example, you can say, now I want to execute on the cluster. And you say, you pass the cluster argument here, and you have some code depending on that. So you can say, OK, now I want to execute on the cluster. So again, that's the idea here, is to help you reduce your development cycle time. Just try to make to be fast. Another way to be fast is to have precise error messages. It's not always easy to have precise error messages. For example, with the file API in Java, when a file is, you try to delete it, you say new file.delete, and you get back a Boolean, okay? So if you want to use that in your example, you're going to say new file.delete must be true. But if it's false, it will say, the failure message will say, well, false is not true. And well, so it's not very descriptive. You would like to have more information on top of that. So one way to add this piece of information inside your example is to add a sentence like that, which describes exactly what was the intention of the code. The email was sent, and in that case, email sent must be true. And if that's not the case, you will have another sentence being generated. No, the email was not sent because the value is false, or because whatever the matcher returns. And another variation of this is to be able to qualify the actual value that you're matching by giving it a name. So if you have a number, that's just a number. So 10 is not equal to, 15 is not equal to 10, of course, but what does that 15 represent? So it's better if you can have an additional piece of text just before the 15 here when you execute your specification. Again, that will give you more information that will help you debug your system faster. And the last trick is when you don't have time to fix stuff, you can just use the pending until fixed annotation. You can even add a custom message, but you don't have to. And then this will display, OK, that works. And then, I don't know, pending until fixed. Implement this or fix it right now. It's not working. I don't want to break the build. I don't have time, but so I just set it as pending. Maybe later on, I'm going to fix the example. In that case, the message is going to be changed, and it's going to tell you, oh, now you fixed the example, so please just remove this annotation. At least you should consider it, because it doesn't make sense anymore. Another thing which I find very useful is when you want to create documentation with specs2 for your app, or you want to specify an API. So in that case, it is very useful to be able to include in your specification text some code directly. So you have two ways to do this. One way is to use snippets, which you can see here. That's a macro that's going to capture the code. And in the HTML report, that's going to report things like that. So snippets is capable of doing several things. So not only it can just capture the code, but it can also execute the code, and it can even check that the result is what you expect. So there's a small API about this code capturing thing. And I can tell you that I've been now rewriting the documentation of 2 major projects, just extracting pieces of code and like this. And the really cool thing is that if your documentation is about code, your documentation is going to be compile time checked. So you will see errors. If you have snippets of code, you will see it because the compiler is going to tell you. And the first time I did this, I had so many errors because there are always typos and things which are not specified and so on. So it's very useful. Another example, which is something you might see if you have a look at the specifications for specs2 itself, is sometimes the API you want to specify is, the code is enough to describe what it's supposed to do. It's short, it's concise, it's like, maybe it's a DSL. So in that case, it would be very redundant to add another piece of text describing what the code already does. So in that case, you can do something like that. There's an EG macro, which is going to capture this, and it's just going to display that thing in the report. So the example is, the code is its own description in a way. So that's for some tips and tricks on specs2, on the current version. And my question, my never-ending question is, can we do even better? Can we fly? Can we make this thing even better? So what's next? At Lambda Jam Brisbane earlier this year, it was beginning of May, I presented what's coming up next. So there are not, basically I'm in the middle of a big refactoring of the internals, and the reason, there are several reasons, but one of them is just that when I started Specs, then Specs2, I was just learning Scala, I was learning functional programming, and I was making many mistakes. So I'm trying to fix those mistakes as I learn more and more. So I started a new refactoring to make the internals a lot cleaner and shorter. But the cool thing is that in the meantime, by doing this, I realized that I could actually do more. I could do something which was absolutely impossible before. So in Specs2, you have a very clear separation between the declaration time of your specification, of your examples, and the execution time. And that's, you cannot, during the execution, create new examples. You cannot do that. But sometimes that's a bit annoying because there are some scenarios for specifications or testing where you want to be able to create things along the way as you discover more stuff. So you interact with the website, you interact with the database, and then you discover some data. And then you want to create more examples to check if this data is correct. So, and this is called online testing in the testing community. So I think with the new implementation, we can now do that. We can now do online specifications. So you can create your specification as you execute it. And for the technical details, the funny thing is that this is all thanks to the flat map operator. So I find this crazily cool that just one operator enables a huge feature. So the other direction that it's going to take is that, well, I want to make it nice and composable, and I want essentially I want people to be able to take the library and maybe write entirely different ways of creating their specifications or reporting them. And so I want to make it more library-like. And if you want to override one part which you absolutely don't like, it should be possible. That means that I'm going to try as much as possible to have all the DSLs being just something layered on top of a more fundamental API, which is hopefully sane and accessible and regular and so on. The other thing which is likely to disappear, and I didn't even talk about it today, because I'm not sure that's very useful and that makes things too complicated, is nested specs. So at the moment, you can include a spec into a spec and into a spec and into a spec. And so it's like a crazy engineer dream where we think that this kind of thing is useful, having this kind of self-replicating stuff. But actually, in terms of implementation and even usage, I don't think this is that useful. So I'm trying to avoid that and propose something else to deal with scenarios where you would think you need nested specifications. And the other thing which is coming up is more modular reporters. So at the moment, it's pretty hard for someone to say, oh, I want a brand new HTML generation in Specs2. I want things to be displayed that way. I want the console output to change and so on. It's not so obvious. Or I want to be able to notify HipChat when one of my specs succeeds and things like that. So I think we can do it. So that's why this is going to change. And unfortunately, there might be some API breaks. I don't like it, but this is why this would be a 3.0. But this is likely to be pretty much at the very low level of. So most of the casual users of the specification are not going to see those changes. It's only if you had in the past to deal with, for example, how examples were created and using an example factory and things like that. For some very specific scenarios that you might have to have some breaking changes. And to finish, how can you help? I mean, do you want to help? If you want to help, you can help. So one big thing, and this has been running forever, is there's no Eclipse plugin for Specs2. So it's like my call to the world. At the moment, I cannot do that, and I'm not sure if I could ever, because I don't know Eclipse. There's a thing with Eclipse. I've been burned by Eclipse before. No, if I was on a desert island for some time, I would do it, but obviously I'm not. So if someone wants to have a look at that, I think that would be really cool to have a dedicated Eclipse plugin. We can have something that looks like an Eclipse plugin for specs2 by just changing or adapting the existing Scala test plugin. And this was there was a prototype of this with a Google Summer of Code project. But because there are some things which are very unique and specific to specs2, I think that would be cool to have an Eclipse plugin. So yeah, I'm sorry, at the moment there's not. If you want to help, please. I'm very bad at HTML programming, JavaScript, CSS. So my current HTML generation, I think it sucks. So I'm going to try to improve it, possibly when it's out, if I have other persons looking at it and fixing it and telling me how it's bad, that can help. It'd be cool. And also, I don't know if any of you know about Pendoc, but I'm going to integrate Pendoc to specs2, so that not only you will be able to output HTML, but also PDF documents, LaTeX, I mean, fun stuff. If you have equations, I would like to represent equations in specifications and have nicely formatted documents out of it. The last part might be web testing. So there was a session on Selenium testing with Scala test. There's no web testing story for specs2, and the main reason for it is that I am not a web app developer. So because I don't need it, I don't do it. So if you need it, if you want it, probably you should contact me and we can see how we can make this happen. So that'd be nice. And that's it. Thanks. So, any questions? Because I can. No, that's not a good reason. Actually, I don't know. Just because I realized that people had really strong opinions on those matchers, on those things. So I started with must underscore equal equal. And for some people, that was really the last thing to do in the world. Have equal equal in a method name was just atrocious. So I said, okay, well, maybe we should not have this and have another way to do it as well. So there are things you can do, maybe not to deactivate all of them, but you can deactivate some of them. So some of them, like must underscore equal equal, they are only provided through an implicit conversion. So this you can get rid of, for example. So if you say, okay, I don't want to see that in my code entirely, we can deactivate that one. If you don't like triple equals, same thing. So I think maybe not in general, but if you really want to restrain the number of choices, we can do something. Yeah, definitely. Cool. Questions? Yeah. Yes. I think that's a very cool idea, and I haven't seen it working. I haven't seen it working, and I think one of the issues is that to write good specifications, and this is why I created specs2. I think you need somehow to be a developer in some ways, because you refactor stuff, because you version stuff. So I think we can do things like that. Definitely, we could provide some tooling. And actually, a few years ago, I was working for a company which now has a product which is trying to do that and trying to give specification tools to business users and so that it's possible. And there's a tool made by ThoughtWorks called Twist, I think, doing this kind of thing. So yeah, it's possible that it's to do something, but if you want to do it with and make it really efficient, you will have at some stage to introduce to the business analyst or whoever is responsible for this specification, at least version control. They have to be aware of version control because you don't want your specification to be out of sync with the code. So all those things have to be kept in sync all the time. So they have to at least understand basically the concept of, I don't know, branches, merges, things, commit. And, you know, I experience it's already hard for developers to get this right. So it might be even harder for business analysts. Yes?
So what are your plans for forms? Do you have any plans?
I don't have any strict plan. I like forms. I've been using them in the past. Yeah, so I didn't talk at all about forms. So forms is a bit of an experimental thing, which I wanted to be able to, again, use tables to specify stuff and have the ability to have tables inside tables and have nice HTML reports where those forms are executed and show the failure messages and so on. So one thing, I'm going to revisit that during this refactoring. One thing I'm going to do at least is try to see if I can put the XML generation out of the form definition. That's one step. But otherwise, it will still be here. I'm not planning to remove it. I like it. Yeah. No? Yes? Okay. Thank you.